So number 6, or example 6, asks us to create the formula for the exponential function shown on the graph to the right. And it says that the graph does cross the y-axis halfway between the grid lines. So if I were to make an input-output table, one ordered pair that they give us is 1, 0.75. And the previous point at 0, if it goes halfway between the grid lines, that means that the output would be 3. Now, we need to figure out what are we multiplying by to get from 3 to 0.75. So how could we do that? Well, we could use a little bit of algebra. So if we don't know a value, we usually use a variable. So we can say 3 times some number. Maybe I'll just put question mark. So 3 times some number question mark is equal to 0.75, which that's another way of saying 3/4. And if I divide both sides by 3, that's on the right-hand side, dividing by 3 is the same thing as multiplying by 1/3. The 3's will divide on the left-hand side, and they will also divide on the right-hand side. So we'll get that question mark is equal to 1/4. So now if we're trying to create the function, we would have y equals our starting value, which is 3, and then our value that we're multiplying by is 1/4, and then our exponent would be x. So that is how we would come up with our function there. Example 7 says, which of the pictures below could possibly be parts of graphs of exponential functions? Answer by writing yes or no next to each picture. Now, you will see examples of this in your homework, but the graph for part A, if I were to connect it, kind of makes this S-shaped graph. That is called logistic growth, or a logistic function. And so that is not exponential, so in this one we would say no. Let's go to part C, and then we'll come back to part B. If I fill in the graph for part C, notice that our graph is decreasing and then it goes back to increasing. So this is more not exponential, but that's characteristic of a quadratic function. So quadratics are either going to go something like that and be like U-shaped, or something like that and kind of look like a mountain. So if you have a scatter plot or scattergram where if you were to connect the ordered pairs and it looked like either of those shapes, we would call it quadratic. And so that is not exponential. If we'd connected them on part B, it would look something like that. And from the examples that we've seen previously, this is exponential. And so we would say yes here. All right, let's move on to example 8. It says the average US retail price of gasoline can be approximated by the function g of t equals that, where t is the number of years after 2000, and the source for this is the US Department of Energy. Part A says this function reveals that gas prices grew at what annual rate? Now, we want to be a little bit careful here. I've said earlier that exponential functions are always of the form y equals a times b to the x power, but notice that we actually have a number here in our exponent, and we want to get rid of that to see and figure out what our b value is. So really, I could rewrite this as not y, but g of t equals 1.5 times e to the exponent 0.0342, and then on the outside of the parentheses, I could put the t there. So my goal is to simplify this thing here to figure out what my b value is. And so I could throw that into my calculator, and that would be 1.5 times something to the t power. So let's go ahead and throw that into the calculator. So I have e to the power of 0.0342. I'm just going to round that number to 3 decimal places. It was 1.035. So there's a couple ways that we could say this. The first way is we could say each year gas prices multiplied by 1.035. But more commonly, because it's between 1 and 2, when we multiply by numbers between 1 and 2, it's usually more common to talk about percentages, and the rate at which it grew is the number after the decimal point. So if I just took that 0.035 and I can convert that into a percentage, and to convert a decimal into a percentage, we move the decimal to the right 2 places. So I would move it 1, 2, and then add the percent sign on it. So a more common answer for this one, we would say each year gas prices increased by 3.5%. Okay, so that's our answer for part A. For part B, it says, what does the gasoline formula predict for the average retail price of gas in 2015? Now, notice in our original problem, it says T is the number of years after 2000. So if we have 2015 here, we want to convert that into the number of years after 2000, which would be 15. So our t value in that scenario would be 15. And what that means is we would want to evaluate g of 15 in our function. So we'd have 1.5 times, and I'm going to use the original function so we don't have an approximation there. So 0.0342 times 15. So I've plugged that into my calculator, and we have, if we approximate that and round it, it would be $2.51. So I'm going to go ahead and round that to $2.51. So we'd also want to write a sentence here, and we'd say, in 2015, we approximate gasoline prices to be $2.51 per gallon.